All right. Good morning, everybody, to this Thursday, where we are continuing our discussion on Babylonian numbers. Trying to keep in mind the big picture of what we're trying to do here, as things get maybe a little strange in appearance. We will see that the Babylonian numbers are we still have a connection to them today. I claim that this very day you have, in some small way, used Babylonian numbers. Now, what have we done so far? We looked at our symbols and saw that we only have 2 of them. Ooh, those are nice. I obviously practiced. You have to practice to make sure that however you want to draw these 2 symbols, it is obviously recognizable as a 1 symbol and a 10 symbol. And then you can make your clusters. For example, we have 2 directions of conversion. We have, let's say, 23 is 2 10s. Now you can put them alongside each other. You can stack them as if it was on clay. They like to stack them 3 diagonally. And then your 1 symbols, however you want to draw them, should be recognizable and a nice tight cluster when it's a single number. Then we saw that, if we have something a little bigger, like, I don't know, 612, then we can only go up to 59 in a single place, a single cluster. So we're going to say, well, this is 10 groups of 60 plus another 12. And then our Babylonian representation will have 2 places for the number of 60s and for the leftovers, or the number of 1s. We'll have 10 groups of 60, 12 1s left over. So this then leads me to the Babylonian number. This is my middle step to help me know what goes where and what should I do to make the Babylonian number. 2 places, just a single 10. Nice big space, another 10, and 2 1s. If you don't have a big space here, then that could be misread as 22. So you want to emphasize that space, changing what the representation is, what the quantity is that's being represented. All right. Everyone good so far? So there are a couple of things to practice, right? Make sure you can draw your symbols in a somewhat efficient way, understanding that we're not working with clay, so it's going to feel a little clumsy. And then when we're representing a number, writing the Babylonian representation, use the space where I need to use the space so that my representation is clear. All right. Any questions so far? Assuming everyone can hear me.
That all sounds good so far.
All right. Now we have 2 places, making the quantities that we can represent bigger. Good. So how big can we go here? Well, well, not us personally, but the Babylonian civilization made the requirement that in a single place we can only go up to 59. So the requirement, that's what they decided, a single, and hence the counting in 60s. Single place can only go up to 59. 59 is represented, of course, by 5 tens and 9 ones, as annoying as it is to draw all these ones. 59. So far, the largest quantity we can represent is going to be 59 groups of 60, a two-place number. 59, let me draw my ones here, space, and another 59, because in any single place, that is as high as I can go. So 59 space 59. That's the biggest number, the biggest quantity I can represent. So this will correspond to 59 groups of 60 plus 59. Let's see what that value is in decimal. 59 times 60 plus 59. It is 3,559. Sorry, 99. 3,599. So now think about what would happen if I look at my very familiar decimal situation and really think about it, which I don't do anymore because I'm so used to it, but let's try. Let's see here, compare with our decimal system where we count in tens. Let's suppose we have two places and they're full. That means 99, right? That means I have two containers here. The number of ones is full. Let's say they're full of 9 little dots. However, it's stacked. It's full because we can only have up to 9 in a place. The number of tens, they're also full. Let's make them little bars. There are also 9 of them. Nice long little bars. For no reason whatsoever. It's full. It's almost overflowing. Okay. Now what happens if I bring in another one? Now I have 10 little dots here. So these 10 dots, let's use some color. And again, it's something that might be very simple to me, but to little Timmy, seeing this for the first time in grade, well, a pretty low grade, it's brand new information, right? And making groups of 10 is a brand new thing that he's going to do. One group of 10 is going to become one of these little bars because I'm counting tens in the next place. Now, let's go blue. Now I have 10 of these. And I don't have space. I'm not allowed to put all of these in that place. So 10 of these will roll over and become, let's say, a square in a new place, which will count the number of hundreds. Why 100? Because it's 10 times 10. 10 squared. 10 groups of 10. So it's really not a problem to make bigger numbers. I just need more and more places. The same thing is going to happen here because it's still a place value system. If I now add 1 here, what do I get? I get 3,600. 3600 is 60 squared. So I'm going to just need a new place. This place was the number of 60s. This place was the number of 1s. If my quantity is bigger than 3,599, I'm just going to have a new place. And that place will be the number of 3600s or 60 squared. Just like in the decimal system, ones, tens, hundreds, thousands, it's powers of 10 because we're counting in groups of 10. Now we're counting in groups of 60, so the place values are powers of 60. But it's not that foreign. Once you go past the appearance and the fact that we're working in 60 and not 10, it works the same way. Okay. So this will allow us to handle bigger and bigger numbers by just adding more places as we need to. So let's see some exercises where we can practice that. Now, of course, the bigger the numbers, the more work I have to do, the slower things go. But the underlying principle is not any different. Okay, let's see. I think I have it here. There we go. So we've done that exercise. We saw the clay, larger numbers is where we're at. It must be this one. No, have we not? We've done this one. Exercise 6.2 we've done. I'm looking for this one. Yeah, 6.3. Okay. So again, right now we're getting used to things. So that means we are just focusing on the conversion from Babylonian to decimal, from decimal to Babylonian. We don't have a lot of different questions that we have to do. This is one of them. Now, I'm going to have to copy all these little symbols carefully. So I'm just going to put it on my other screen and not jump back and forth and make a mistake. The first thing to do is to, of course, make sure you can read the Babylonian number correctly. So I will copy it. I have 2, then a space, then 5 tens and 2 ones. And let me know if I'm writing this down wrong. It can very easily happen. I see 6 ones in this last place. So that's my Babylonian number. And make sure you get used to the font that's used in the book because that'll be used in any test as well. So now I can write here, I can write stuff. And I should write stuff because instructions on the test will always say, show sufficient work to justify your answer. So you should, even if it's obvious to you, oh, I know what this number is, you should humor me and show more work because with teaching in mind, finding the answer is useless. It's explaining yourself that has value. So I now see I have 3 places. Actually, I'm not going to do it like this. I'm going to give myself a little bit of space here. I have 3 places. So right to left, left to right, doesn't matter. Left, because I read left to right, it's going to be the number of 3600s, which I know is 60 squared. You can write 60 squared. You can just remember that it's equal to 3600. It's the same thing. Then I have the number of 60s. Then I have the number of 1s. So in the 60 squared place, I have 2. And I'm writing it in brackets because I'm not done. I'm just trying to decipher what this Babylonian number is telling me. Then I have 52 in the 60s place. Then I have 16 in the 1s place. That means that I should not put it there. I'm running out of space. More curly brackets. That means we have 2 groups of 3600 plus 52 groups of 60, and that's multiplication, plus 16 groups of 1. I just write 16. Now, you do not have to do this in your head. Let's get a calculator, practice with whatever calculator you're going to use, and see what we get. 2 times 3600 plus 52 times 60 plus 16. And we get 10,336. That is the quantity that this Babylonian number is representing. All right. So far, so good, I hope. Feel free to interrupt me if you are not sure. So this direction is a little bit easier because the places are clearly visible. The value of each place should be clearly visible when you know how to translate them. And then we just plug it into the calculator, essentially. But we'll practice a couple more just to be sure, because that is all we're doing today. So why not take our time, see if everything makes sense, and ask questions if it doesn't. Next one, I'm going to copy it down. I'm looking at the book. I have a 1, and then a space, and then 5 tens. They're just getting me to practice my tens, which get a little curvy that I have to watch out for. Then it looks like I have a 7. And then I have a space, and I have 3 tens. And then I have 9 ones, because why not? That's always fun to practice all my ones. And then I have another space. Ooh. And then I have 4 tens and 6 ones. So even though it seems silly, these things are in the book, why are you copying them down? Because I need to practice my symbols. I need to practice. So now I see I have 4 places. But there's no limit to how big the quantities can be now. Let's go maybe right to left. It's always going to be the number of ones, number of 60s, number of 60, whoopsie, where's my of 60 squared, number of 60 cubed. Just like ones, tens, hundreds, thousands, and so on. There's no end. I can keep going if I need to, and this number needs to. Then I simply look, what is in each place? Well, there's a 1 there. There is a 57. There is a 39. There is a 46. See, I help myself with smaller steps to, first of all, show my work and defend my answer, show that I understand how to do this. Here is how I did it for all to see. And to make the steps easier for me to not be overwhelmed and have to do a lot all in one. So this then means I have one group of, maybe let's write it like this, because maybe at this stage I don't know what 60 cubed is. I can write it like that, let the calculator worry about it. 57 times 60 squared, 39 times 60, and then 46. And let's see what that is. Calculator time. I encourage you, if you maybe watch the video after the fact, pause, see if you can get the answer. Don't just sit back and let me do it. It seems easier, but in the long run, you're not really getting that skill that you might need to practice. So let's see here. We have 1 times 60 cubed plus 57 times 60 squared plus 39 times 60 plus 46. And hopefully you can confirm 423,586. That was a wild circle. Maybe just underline it. There we go. So when you look at it, the method for converting from Babylonian to decimal, figure out how you are going to present that. That makes sense to you. And then always do the same thing. Now, if I have any conversion question, starting with Babylonian, and I need to find the corresponding decimal number, I know what I'm going to do. I'm going to write it like this because I'm comfortable doing this. I've practiced doing this. Don't go to the test and then suddenly do something different. No, do what you've practiced. That's why we practice. Maybe you don't like this many steps, but you should explain yourself because what if I made a calculator mistake? What if my finger slipped and I accidentally pressed the wrong button in the calculator step? Now my answer is wrong, but I want to lose the minimum amount of marks by showing that I did understand how to do this. There is no doubt that I understand, and it was just a little silly mistake. But if you just write your final answer and that's wrong, then you lose all your marks. And I see it happen all the time. Despite the instructions saying show work, people don't. Can we squeeze that in here? I think we can. Ooh, I'm copying the number. I have 4 tens. Okay, make my tens more pointy. Come on, pointy 10. Oof, that was not good. Pointy. And 3 ones. Ooh, nice and long. Space. 3 tens. Pointy. Pointy. And 6 ones. 6 ones. And then I have 4 tens. More tens practice. Pointy. 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 As good as it's going to get. As long as they're recognizable, that which one's a 10 and which one's a 1 and where the spaces are. Okay. Then I see I have 1, 2, 3 places. Left to right, right to left, I don't care. Number of 60 squared, number of 60s, number of 1s. If I can write this out every single time, so can you. So what's represented in this place? 43. It's actually, I think, easier than Roman in many ways because there are only 2 symbols. I don't have to memorize anything. 36 and 40. I can then, before going into your calculator, I write down so I show I understand how this is put together. Whoopsie. Times 60 plus 40. Then the calculator. Just in case I make a little calculator mistake. They happen. Let's see. Well, that's not what I want to do. Wait, I have a Discord problem. Hold on here. Okay, I think it's better now. Let's see here. 43 times, I know 3600, plus 36 times 60, plus 40. And MathBot says, ooh, nice round, 157,000. Now, of course, I cannot look at this Babylonian representation and see 157,000. Of course not. They could, but they grew up with that number system. It was the only number system they knew. It's very hard for me to really be super efficient in this new, quite foreign-looking number system. I'd have to grow up with it. But to them, I'm sure, these symbols and this counting in 60s was as natural as our decimal number system is to us, where you stop thinking after a while. You're just making your symbols and doing what you do. It's hard to imagine, but it must be true. Right. So now the next thing to do is to make sure we can convert the other way. Just trying to fix my Discord here. I'm extremely zoomed in by accident. There we go. I fixed it. Okay, so that's one conversion direction. Let's see what the other direction looks like. Assuming everyone is still awake, there is a chance that I have talked you to sleep. Babylonian numbers are very comforting. It's true. So I don't blame you for falling asleep. It's like a warm blanket of numbers. Okay. Other direction. That would be 2. A is first. So our number is 23,596. That's our number. But now, it's not as easy for me as 612 was, for example, to just split it up into 60s and so on. The number's a little big. I'm not too sure about this. So I need to maybe help myself. Lay it out in a way that I can see how to break this number up into powers of 60, because that is my goal. So here is how I'm going to do it. Do it like this. Don't do it like this. Do whatever you want to do, but have a way to confidently split up this number. So I'm going to look for which power of 60 I'm going to need to use. So I need to fit in the largest power of 60 here. The largest power of 60, well, I know 60 squared is 3600. And 60 cubed is 60 cubed is 216,000. And that's going to be too big. It's not going to fit into my number. So the largest power of 60 is going to be 60 squared, which is 3600. And then I'm going to ask, how many times can 3600 fit in there? How many can fit in there? How do I do that? That is exactly the intuitive concept of division. How many times can something fit into something else? So I go, the number 23,596 divided by 3600. 23,596, I made a typo. 23,596 divided by 3600. MathBot says 6 and a bit. So it can fit 6 whole times. Then I want to know, I haven't used all the number. How much have I used? That'll be 6 groups of 3600. 6 groups of 3600. So I've used, oh, that line's annoying, I know, 21,600. I still have a little bit left. So I can figure out what's left by way of a subtraction. Let's show the subtraction as well. And you have to be able to do all this, of course, in one way or another, whether you use a table to make it systematic and easy or not. So 23,596 minus 21,600. And I have 1,996 left. Now my next group will be the groups of 60, or groups of 60. 60 to the 1, it's just 60. How many 60s can fit in what's left? Maybe you can do it in your head, maybe you can't, it doesn't matter. I will show it on the chat anyway. So 1996 divided by 60. Silly line. And I get 33. 33 60s can still fit in what's left. And then I need to figure out how much have I used of that 1996. And that'll be 33 times 60. Get rid of my line. And I've used 1980. And you see here, okay, I still have 16 left. Don't need a calculator for that. And the 16 will be picked up by the ones, which is technically a power of 60. 60 to the 0, though you don't have to worry about that. The leftovers. All of the leftovers are used. Nothing is left. And I'm done with my breakdown. So let's write it underneath here. So what I have is 23,596 is 6 groups of 60 squared plus 33 groups of 60 plus 16 ones. But I needed to do that because that's what the Babylonian number is going to need. It's going to count in number of 60 squared, number of 60s, number of ones. And in the 60 squared column, there needs to be the corresponding representation for 6. In the 60 column, 33. And in the ones column, 16. Now I just have to translate it to the appropriate symbols, which I will do. 6, well, those are just 2 rows of 3, space, 33, 33, space, 16, a 10 and 6 ones. And I am done. So this direction for the conversion it has a little more to it, wouldn't you say? But again, find a way through this that works for you. Maybe you don't like the table. Maybe you just want to write the answer. Well, you have to show something. Maybe you want to go right to this breakdown step. If you can do that with confidence, go ahead. I need to see this breakdown to verify that you have the right representation and you know how to get it. So at the very least, the circled bit needs to be shown. The rest is there to help me personally. That's my strategy for how I can confidently work my way through this. It's not necessary to copy everything exactly how I'm doing it, but you need to show enough explanation to justify and sort of defend your answer. All right. How do we feel about this direction for conversion? Still stunned silence. Fair enough, fair enough. Maybe I feel like I just need some practice. It's surprising what can be fixed through practice. So let's do it. B. I have my number. My number is 548,456. I have established how I am going to do it. This is my personal choice. That helps me feel good and confident, and I'm going to stick with it. So I want to know which powers of 60 can I use. I will look at how many of those, once I look at a specific one, will fit. Ooh, that's a wobbly line. I'll see how much I've used at that stage and what is left. That is what I'm going to do. So now I've seen before, 60 cubed is 216,000, and that's definitely going to fit here. So I'm going to have to start with 60 cubed, 216,000. It's convenient to memorize 216,000. Once I do that, I cannot skip any power of 60 anymore. That's a 0. I have to look at the 3600s. I have to look at the 60. I have to, of course, mop it up with the 1s. So then my first question is, how many 60 cubes can fit in my number? Well, it should be 2. And I've used 432,000. Sometimes the arithmetic is easy. Sometimes I need a calculator maybe to be 100% confident. It's totally up to you. Then how much is left? Maybe you want to do it. Maybe you want to do it in your head and then verify it with a calculator. That's up to you. It's up to you. 116,456. Maybe I'm not that confident, right? Maybe I want to do some mental arithmetic when I get a chance, but I also don't want to risk making a mistake, because an early mistake is going to lead to a whole bunch of problems. So double up with a calculator. It's okay. So 548, 456 minus 432,000. And then maybe I see, oh, I am right, or oh, I am wrong. Either way, I'm more confident. Now I want to see how many times can my 3600s fit into that. Well, that's a bigger number. I'm going to have to do some division. 116,456 divided by 3600 is 32. And then I want to know, of what was left, how much have I used? So it's multiplication. 32 times 3600. And I see that I've used, as soon as MathBot decides to actually work with me. Come on, MathBot, you can do it. I don't think MathBot can do it. Wow, MathBot's on strike now. Really? Oh, it's because I only put one equal sign in. Such a doofus. 32 times 3600. MathBot doesn't know what I'm doing if I only put one equal sign in. I've used 115,200. Which is not all of what I had. Maybe I'm confident. I can do the subtraction. 1,256. Maybe I want to verify with a calculator. Totally up to you. Then I want to see, oh, how many 60s can fit into what's left. Maybe you want to do it in your head. Maybe you don't. That's totally up to you. Just be confident in what you're doing. 1,256 divided by 60. It's nice to verify anyway. Nice to verify 20, as I maybe suspected. Then I've used 1,200. And I see I have 56 left. Not quite enough for another group of 60. It was close. But the ones will have to mop up all that is left, and nothing is left after that. So now I'm ready to say that my original number, which was 548,456, is 2 groups of 60 cubed plus 32 groups of 60 squared plus 20 groups of 60 plus 56 left over. That means, and I'm writing a lot, so it helps me, and there's no confusion. I have my places, but this is an optional step for sure. Number of 60 cubed, oops, number of 60 squared, number of 60, especially in the beginning, when I'm trying to get on top of what the Babylonian system is telling me and how it works. It's nice to have this extra step. 2 32. A lot of people make mistakes that I think a step like this can avoid, but I have to know where I'm at and what I need and adjust accordingly. No one can really answer that for you. So I'm going to have a four-place number, 2 space 32 space 20 space 56. 56. There we go. Okay. It's a big question. Absolutely. Now, we're not going to make it super big, right? Yes, we can have more and more places, but we won't go past 60 cubed. There's no benefit in doing that. I'm also, in the interest of saving time, going to leave the last exercise because it's just more of the same. Feel free to practice this 159,452. You can send me your answer, verify that it's correct. It's just more practice that you can do. But I think these two examples should be sufficient in illustrating that you need to make a plan, stick with the plan, and how one way could look to help you do this conversion. There is one small little issue that some of you may have noticed, and some of you may not, but it's still there. That, let's say here, issue. It's not a big issue, but it is an issue. How do we represent one decimal number versus 60? Now the 1 is obviously 1. The 60, however, is one group of 60 plus no ones, which will then be 1 space nothing. So it's very easy, they found, in calculations, these are among other numbers, to misread the spacing. How much space do I give to make it clear that this is a two-place number and the ones place is empty before I start writing more stuff, where I wouldn't do it here? It can be very confusing and be misread. And suddenly I have to pay tax on 1 chicken when I actually have 60 chickens as a farmer. That's a problem. So they very quickly realized that people are misreading the information and getting confused. We need to make it clear that there is a second place here. There are 2 places here, but the one place is empty. So they didn't want to swap out their stylus. They wanted to use the same instrument. They just wanted to angle it in a slightly different way to make a new symbol that essentially represents nothing. And they just wanted to make 2 little triangles so that their symbol is still recognizable and different from the symbols they are currently making. So it can be a third symbol, an empty symbol. Now it is actually equivalent to 0, even though they didn't really think of 0 as a number, interestingly enough, at that time. You can certainly think of this as 0, but I need to have something visible to show the difference between these 2 numbers, for example. When I have nothing in a place, I need to show that so that it's not misread. Okay. So let's do a couple of examples with that over here. So in the book, it sort of looks like triangles, I guess, in exercise 6.4. Now, it always happens that I'm not trying to be lazy here. We don't need to do all of these exercises, I feel, in class or on a video, it's essentially all the same with the exception of this new little empty place symbol. So I will do the first one of each, and I leave the others to you as extra practice. So the two conversion directions are still what we are doing. I have 6 ones there. I'm just copying it down. Space, empty symbol, space, 2 tens, and 5 ones. So that is going to be my number of 60 squared, number of 60, number of 1. Maybe I want to skip that middle step and just say, well, this is then 36. 36 groups of 60 squared plus 0 groups of 60 plus 25 ones. But I can't, I have to address how many 60s. In this case, there's nothing. Let's see what MathBot says. 36 times what I know is 3600. I don't have to write the 0 because it's not, the middle won't contribute anything. So I can skip that in my calculator for sure, but I want to write that to show that I understand. 129,625. So nothing is changing in how I'm handling this. It's just a new symbol that came out of necessity when they quickly realized that spacing, maybe the Romans could get away with that, but it's not going to work for us as well. Okay. So it's just a little empty place symbol that I have to use when there is nothing. Think of it as the 0, which I didn't have up to this point, and I kind of need it. Now I want to do just one of the other directions. So I have 43,256. Nothing's changing. I know how I'm going to do this. I'm going to look at powers of 60. I'm going to see how many times can it fit. I'm going to see how much I've used, and I'm going to see what's left. Absolutely nothing is going to change in how I approach this. Largest power of 60 will be 60 squared, 3600, because the next one up is 216,000, and that's too big. Once I've done that, again, I cannot skip any other power of 60 that comes after that. So I then check how many times can 3600 fit in. That's calculator time for sure. 43,256 divided by 3600, and I get 12 times, 12 whole times. Can it fit? Well, 12 times 3600. Did I do that right? 43256 divided by 3600. Yeah. Okay. Then how many times can that fit? Well, that's a multiplication. 12 times 3600. And I see that I've used 43,200. I have 56 left. Obviously, the subtraction should be fairly easy. And that shows me that I cannot fit in any groups of 60. 0 groups of 60 will fit. I've used nothing more. 56 are still left. But the ones will get them, using all of them, and nothing's left. So that then tells me that up here, the original quantity can be split up as 12 groups of 60 squared plus 0 groups of 60 plus 56 left over. So all we have to do is convert that to our 3-place Babylonian number system. It's in the Babylonian number system. Convert that to our specific Babylonian number, which is a 10 and 2 ones, space empty symbol, space, 50, 56. And there we go. Let's put a box around it. That's my answer. So it's not a big step to become comfortable with this empty symbol. Everything is staying the same. It's just sometimes I'm going to have a 0 in a place. Yet I don't have a 0 symbol. So I need an appropriate symbol, which is a new symbol, technically. All right. How do we feel about that? Any questions?
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.